Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to solve exponential equations. This is another round of that. These are a little different. Notice in the two that are on the screen and the one that's about to be on the screen, the base is e. And so an important property that we're going to use this time is the fact that the natural log of e raised to some power is simply equal to that power. Natural logarithm and e are inverse functions of each other, but also if you think about what natural logarithm represents, this is the log base e. And so what we're really saying here is e to what power will give me e to the x power, and we know that that's x. Anyway, the good news is when you see a logarithm, an equation that has a base of e, taking the natural log of both sides will just clear out, take that exponent and put it on the main line of the equation. So it makes our work a little easier with the calculator on the back end. For this one, we've got e to the absolute value of x minus 2 equals 10. This is going to not only go over solving an exponential equation, but it'll give us a little review about our absolute value equations. Let's start. The natural log of e to the absolute value of x minus 2 power equals the natural logarithm of 10. On the left side, by what I had mentioned up here, we're left with the absolute value of x minus 2 equals the natural logarithm of 10. Now, remember that when we're solving an absolute value equation, we take what's inside the absolute value and set it equal to both the number on the right side and the opposite of it, provided that that number was positive to begin with. And natural logarithm of 10 is positive. So we get either x minus 2 equals the natural logarithm of 10, or x minus 2 equals the opposite of the natural logarithm of 10. Couple of things from my experience with students in the past is that you've got to be really careful here in solving this. So one thing that we could write for this first equation is add 2 to the right-hand side and get x equals the natural log of 10 plus 2. And at that point, a lot of students are tempted to add the 10 and the 2. So one thing that you can do to avoid that is by putting the 10 in parentheses from the beginning so that you know that it's attached to that natural logarithm. The other thing that you could do is you could put the plus 2 in front of the logarithm. 2 plus the natural logarithm of 10. Then there's no worry that you're going to add those by mistake. You're going to be checking your work and you're going to see 10 plus 2 on your paper, and it's a pretty natural inclination to replace that by 12, but the 10 is part of that logarithm, and so that can't happen. We'll approximate this on the calculator in a moment. The other one, using that approach, the second approach that I mentioned, x equals 2 minus the natural logarithm of 10. So let's go to Desmos to get the approximations. I want to start with 2 plus the natural logarithm of 10. 2 plus function ln main 10. And there to 3 decimal places, I got 4.3025. That's going to make 4.303. So let me write that down. And for the other one, I never pressed enter here. And so what I could do is I could go back and just change that plus sign to a minus sign. And I get negative 0.303. Now the bad part about this is when you go to check your work, did I get that 4.303 right? It's not on the screen anymore. So I do think that it's a good idea to retype it. 2 minus the natural log of 10. So again, negative 0.303, but now I can see my previous answers on the screen and I can make sure that I type that correctly. Right, let me copy that over. X is approximately negative 0.303. The second one, We're going to use some properties of exponents to simplify that equation before we take the natural logarithm of both sides. We have e to the 3x power times e to the x minus 2 power equals 4 times e cubed. I know that a to the m power times a to the n power can become a to the m plus n power. That tells me on the left-hand side, I can add those two exponents together over one common base of e. And when I add 3x plus x minus 2, I get 4x minus 2. Now, this may seem like a good time to use the natural logarithm, but I have an e to the third on the right-hand side that I can bring over to join the e on the left-hand side. And now I can use this property of exponents, a to the m power divided by a to the n power is the same as a to the m minus n power. So I can subtract the exponent in the numerator minus the one in the denominator. 4x minus 2 minus 3 gives me 4x minus 5 equals 4. Now this equation is much simpler to work with. I can take the natural log of both sides. Remember that the natural logarithm and e undo each other here. So the left-hand side is just 4x minus 5 equals the natural logarithm of 4. To solve for x, I need to get rid of the 5 first. And so if I add 5 to both sides, I'm going to sneak that in front of the logarithm. 4x equals 5 plus the natural logarithm of 4. And then I can finish by dividing both sides by 4. X equals 5 plus natural log of 4 over 4. And again, this is the exact solution. We can approximate it on our calculator to 3 decimal places. Let's do that. Let me clear everything out of the way. So we had 5 plus, oops, I want to put this in a fraction, so let me do that first. Fraction key, 5 plus function natural logarithm of 4, and then in the denominator, type 4 again, and there we've got 1.5965. That's going to round to 1.597. And that is the approximate solution. So good thing to remember, if you have the same base showing up 2 or more times, you can use the rules of exponents to combine those into one. If I had taken the natural log of both sides, it would have been a mess, but we would have used the properties of logarithms instead. I think using the properties of exponents to clean it up first is definitely a better bet. All right, one more in this video, and here, this is a quadratic in terms of e to the x power. And I want you to think about, how would I solve this equation? X squared minus 7x minus 18 equals 0. Well, I would factor that to be x minus 9 times x plus 2, and I know how to solve from there. Well, this is really the same type of equation. What I have is e to the x power squared minus 7 times e to the x power minus 18 equals 0. That e to the x power is really taking the place of x in this other equation. So I can factor the same way. This is going to be e to the x power minus 9 times e to the x power plus 2 equals 0. Now I can set each factor equal to 0 and solve. E to the x power minus 9 equals 0. E to the x power equals 9. I can solve that with the natural logarithm. Natural log of e to the x power equals natural log of 9, or x equals the natural log of 9. So I've got one solution. Do I have a second? I don't. Where does this go bad? E to the x power plus 2 equals 0. E to the x equals negative 2. If you remember, the range of the exponential function e to the x is parentheses 0 comma infinity. It's it's non-negative, it's actually positive. And so here, it can never be equal to a negative number. So this is the best place to say that there's no solution from this branch. However, you may miss that. And so you may go through the motions and try to solve that by using the natural logarithm. Okay. Your second chance to catch it is to know that the argument of a logarithm has to be positive, and -2 is not positive. So this one has no solution. But you might miss that too. That's okay. You can catch it on the next round when you go to the calculator and try to do the natural logarithm of -2. So these are the potential solutions, but we're going to see that the second one is going to get thrown out. So let's do natural log of 9 and natural log of -2. Or let's try to do those. First, function natural log main 9. And we've got 2.197. And for, oh, I transposed those. I had a feeling I did that. 2.197. Going back to try the other one, our third chance to see that there's no solution, function natural logarithm main -2. And you can see on the right hand side it says undefined. So now I know that that's not a solution. And so there are no solutions that come from this branch. The only one is the one that came from the factor e to the x minus 9. All right, so that's 3 more types of exponential equations. The first one, after we use the natural logarithm, and remember this fact when you're working with e to some power in an equation, natural log of both sides, and then we solved the resulting equation, which was just your run-of-the-mill absolute value equation. The second one, we had multiple instances of e as a base, and we're able to combine those all into one before taking the natural logarithm of both sides. And here, this was a quadratic in hiding. It was a quadratic in terms of e to the x. Now, another thing that you could have done here is make a u substitution. If you let u equal e to the x, your equation would have been u squared minus 7u minus 18 equals 0. That would have got you to u equals 9 or u equals -2. Then you could have back substituted and been right back where we were. So if you struggle to factor using e to the x, try using the u substitution instead. All right, that's it for this one. I'll see you in the next video where we'll solve more equations.